Here is the third video for Section 12C, where we're going to be looking at 3 examples using Jefferson's method to split up representatives among a population. So for Jefferson's method, we start off pretty much the same way. We're going to find our total population by summing the population of the different states, and then find our standard divisor by taking our total population divided by how many representatives there are, which in this first example is 100. And then we're going to find our standard quota by taking each state's population and dividing it by our standard quota. What's my computer doing? I want to lock in that cell. There we go. Remember, you hit F4 to lock in a cell so that when you drag down, it doesn't change the cell reference. See how when I drug down, it went from referencing B28 and B26 to B27 and B26. So it kept that standard divisor reference the same, which is what I wanted because it's not changing. Okay, so once we have our minimum quotas, we find our standard, or once we have our standard quotas, we find the minimum quota by rounding each of them down. And if you add the minimum quotas, they only add to 99. And when we had Hamilton's method last time, what we did is we took that extra person, that extra seat, and gave it to whoever had the highest decimal place. But because you had issues, like the Alabama paradox would sometimes show up, Jefferson came up with a different idea, and he said, all right, let's not divide by a standard quota. We're going to guess and check and try modified quotas to see if that'll fix the problem. So Jefferson's method has a little bit of guess and check in it. So we're going to start by trying number 99 instead of 100 for our divisor. So when you're guessing and checking different modified quotas, you always go with smaller numbers. So you don't want to go bigger, you want to go smaller. So now we're going to divide by 99 instead of by our standard divisor of 100. So I'm going to take my population and divide it by my modified quota, which is 99, and do that for each of them. And now find my minimum quotas by rounding each of them down. And if you notice, when I sum them up, they only sum to 99. So we're still not apportioning all 100 seats. We only have 99 of them. That didn't work. We need to try again. So same thing, but now we're going to try the modified divisor of 98. So just for practice, I'm going to fill in the first part of the chart by finding my total population, and then my standard divisor is my population divided by the 100 representatives. Standard quotas, population divided by my standard divisor. This is exactly the same as we did before. Minimum quotas, round them down. And the reason we have a problem is because when I sum my minimum quotas, they don't sum to 100. So we tried earlier dividing by 99. That didn't work. Let's try dividing by 98. So I'm going to take my population and divide it by my new modified divisor. Remember, this is kind of a guess and check process. Pull it down, and then find these new minimum quotas. Now when I add them up, I get 100. So that's what we want. We want, in Jefferson's method, we want our minimum quotas to sum to the number of seats. So this would work. If we were using Jefferson's method, this is how we would split up our representatives among the 4 different states. State A would get 9, State B would get 27, State C would get 26, and State D would get 38. In this class, we will either give you a minimum or a modified quota to try, or we will give you a limits. We might say try 5 different modified quotas, show your work, and if you don't find a number that works within 5 guesses, you can stop. So sometimes we'll either give it to you so you can go straight there, or we'll tell you how many times to kind of guess and check, and then if you haven't gotten it to work, then you can stop and not worry about it. But please know that we're not going to make you go hundreds and hundreds of guesses and checkings to find it. There will always be either a given value or a limit on how much work you should do. Let's look at one more using Jefferson's method. So now we have a different country with a different population. Let's find our total population. So these 4 states have different numbers of people, but they still sum to 10,000. And divide my 10,000 people among my 100 representatives. So to find our standard quota, we would take each country's population and divide it by my standard divisor. Let me pull that down. All right, so what the quota criteria says is that when you assign the number of representatives per state, it should be really close to the standard quota. In fact, it should either be the standard quota rounded down or rounded up. So what this says is when we do our apportionment, state A should either get 6 or 7 people because 6.8 rounded down is 6, rounded up at 7. State B should get 16 or 17. C should get 10 or 11, and D should get 65 or 66, saying that if you're going to be fair, you should get either your standard quota rounded up or rounded down. You should be as close as possible. All right, so let's just look at the minimum quotas for this one. So we'd have 6, 16, 10, 65, and if we sum them up, we have 100 seats, but we're only apportioning 97 of them. So for Jefferson's method, we're going to try different divisors. So now we're going to try a divisor of 98. So we're going to take each population this time and divide it by 98. Finding the minimums, rounding down, we get 6, 16, 11, and 67. And when I sum them up, they sum to 100. So from first glance, this looks really good. But there's actually a problem. State D does not meet the quota criteria. The quota criteria says that state D should get either 65 or 66 representatives, and it's being assigned 67. So that's not really fair according to the quota criteria. So we found a divisor that works for Jefferson's method, but it assigns a state too many seats. So that is Jefferson's method. I'm going to end this video here. In our next video, we'll talk about Webster's and the Hill-Huntington methods.